To make the electronic circuit that is really the brains of the nightlight, you need to have a printed circuit board. This circuit board is a thermosetting material with copper tracks etched into the top of it that allow us to connect the components in our circuit together in the proper way. It is a good idea to prepare the copper tracks by just rubbing them down with a bit of wet and dry paper, rubbing off the green coating that comes out of the etching tank to reveal the copper beneath, as shown in the picture. This will make it easier to solder and have the solderer stick to the copper tracks and make successful electrical connections to the components. You'll need to use the pillar drill to drill out holes for each of the component legs to go through. Carefully position your circuit board underneath the pillar drill and use a 1mm drill to drill out every hole that is located on the circuit, ready for the circuit components. Here is a close-up of the PCB being drilled. Here you can see we're trying to locate the 1mm drill in the centre of each of these round circles on the copper tracks. Everywhere we see a circle, we should be drilling a hole ready for the leg of a component to come through, ready for soldering. This is a complete circuit board. You can see the holes drilled ready for the component legs. Try to get all of your holes in the centre of each of those circles as far as possible for ease of soldering. This picture attempts to show how we orientate our circuit board in relation to where we should put each of our components. We are looking at the plastic side of the board with our copper tracks facing away from us. This is the correct orientation and the correct way round we should put our components into the circuit board. It's suggested that you start with the light dependent resistor, the component on the left in this picture, and the fixed resistor, the component on the right in this picture, as the first two components to place in your circuit board for soldering. Orientate your circuit board with the plastic side facing you and the copper tracks facing away from you. Bend the legs of the fixed resistor and push it into the right holes all the way down to the circuit board. Pull the legs a little bit apart to stop it falling out, then turn it over, hold it in a stand and get ready to solder it. Bring your soldering iron into the join where the leg and the copper track meet. Hold the soldering iron flat so that the whole area can get warm. Remember, the soldering iron is there to get the join hot, and the leg and the copper track need to be hot before bringing in your solder. It's suggested that you count to 5 before bringing in your solder. Put the solder onto the joint and it should melt instantly. You can tell that you've done a good solder joint because the solder joint afterwards should look like a small volcano rather than a kind of pebble shape. If you get a pebble shape, then it's better to just get the copper track hot around the joint again and let the copper sink in and stick to the copper track and form this volcano shape. This picture shows an example of what we mean by a good solder joint. You get this kind of volcano shape where the copper is got hot and the solder has flowed and stuck to the leg of the component and the copper track. This picture shows a bad solder joint where the solder has balled up and looks like a pebble shape or a ball and isn't sticking to the copper really and isn't sticking to the leg of the component. The next component to put in place is the LDR, the light dependent resistor. Just make sure when you put it into your circuit that first of all it goes into the right location and it just sticks up about 1 centimetre as shown in this photograph. Once it's in the right position and sticking up, just flare the legs out a little bit, turn it over and solder it as you did the fixed resistor. The third component to locate is the transistor, which looks like this. The transistor has 3 legs called the gate, the drain and the source, and they are labelled from left to right, gate, drain and source. It's imperative that the transistor is connected the right way round in the circuit, otherwise it won't work. This picture shows how the transistor should fit into the circuit. You can see that the front of the transistor is facing in towards the circuit. This will ensure that the legs are in the right holes and connected to the right parts of the circuit. The fourth component to solder in place would be the switch. The switch may have red or black leads, or it may have two red leads or two black leads. It is unimportant which way round you connect the switch. The fifth component is the battery connector. This will have red and black leads, and it is crucial that you connect them the right way round, otherwise the circuit won't work. Remember that the red lead is the positive and the black lead is the negative. There should be positive and negative signs actually on the printed circuit board to help you locate where these go. The last component to go in is the bulb holder. But before we actually solder the leads of the bulb holder in place, we need to thread them through the little casing that holds the circuit, as shown in this picture. Feed the bulb holder through its little casing from top to bottom. With the bulb holder in place, as is shown in this photograph, you're ready to solder the leads in the last two places in the circuit. This should be the complete arrangement of the circuit. We can see all our components and the bulb holder in place in the casing, ready to be put inside our vacuum form casing of the nightlight. Get your circuit tested, and when you know that it works, trim off all the legs of the components nice and close to the circuit board. This will prevent them being folded over and maybe inadvertently connecting part of the circuit together which shouldn't be connected, otherwise known as a short circuit, and causing your circuit to malfunction. After that, the circuit is finished.